All right, welcome to this lesson on solving word problems with one variable. And this is sometimes a bit of a challenge for students, as word problems always seem to confuse them a little bit. And it's taking sort of more the reality of life and bringing it together, connecting it with some of the mathematics that they have learned. And we're going to try to break this down into a series of steps that really help you along. Now, one of the most important things is make sure you read the question and read it well. I'd even say read it twice if you need to, just to be sure that you go over things. It goes without saying that you have to be able to read and follow that question well in order to be able to solve this. Now, the next step along the way that I'm going to use is we want to create a variable or state a variable. Use a let statement to do this, and let the variable be what the question is asking for. It's really important that you recognize what is it that the question is really asking and state that in your let statement by letting your variable. I generally use the letter X, but that's not necessarily how it has to be. For example, lots of students, if they're looking for distance, might choose the letter D as opposed to using the letter X, and that is just fine. The good thing about doing this is that once you solve for X, once you find what X is, you've answered the question essentially, and you don't really have to do much more other than make a concluding statement. Now, we're going to use the information in the question to create an equation, and this is by far the most difficult thing that students tend to have. They really struggle with this part of the equation, or this part of the question or process of solving word problems, right? And I'll try to break it down through some examples, but I mean, at the end of the day, it's a skill that needs to be developed, okay? You need to work on it. And then you solve the equation for the variable, which is probably easier to do than many of the equations we've been working on, so you don't have a lot of difficulty on that side. And then you write a concluding statement. And often students sometimes forget to do that, and that does cost them some minor marks. But those are the 4 steps that you want to kind of keep in the back of your mind that you need to do when you're solving a word problem. All right, so I'm going to move down. I'm going to scroll down here, and we're going to work on these 2 examples that I've set up here. And they are not very difficult, but they kind of break down the way we do things, okay? So if 3 consecutive odd numbers have a sum of 39, what is the middle number? So let's repeat that. If 3 consecutive odd numbers have a sum of 39, what is the middle number? Well, first of all, do you understand what 3 consecutive odd numbers means? What's an odd number? Well, most students will know that odd numbers are like 1, 3, 5, 7. So I could just jot some of those down. 1, 3, 5, 7. Let's pretend we'll take these 3, 9. We'll continue on here. Let's just take 3 simple ones, 3, 5, and 7. If we were going to add them all up, that's what we're looking for, and it must have a sum of 39. Now, some students will just simply start picking numbers randomly and keep working their way up until they find the 3 odd numbers that add to 39, and that's wonderful. That's sort of a deductive trial and error system where you can solve it, and it would work reasonably well even with this question. But if I gave you a number that was really large, it might take you some time to figure it out, whereas a student who uses the method I'm going to use could do it consistently the same each time. But if we did use 3, 5, and 7, you can see 3 plus 5 is 8, plus another 7 is 15. And so that's not the correct 3 that we're looking for. But we can use this as an example to help us better understand how to solve it. Now, the question ultimately asks, what is the middle number? So whatever they're asking us, that's what we must write in our let statement. So we say, let X be the middle number, okay? And we write this down. This is very important, okay? That middle number of the 3 consecutive odd numbers, okay? And a lot of students will fail to do this, and that is really the first part of demonstrating an understanding of how to solve this, okay? So please don't avoid or not do this. Please put it down, show me, demonstrate that to me, because that's worth some marks and showing or demonstration of understanding. Now, once we do that, then you can kind of go like here. Think of x as being like 5, because if we were talking about 3, 5, and 7, right, x would be the middle number. Then we can say then the smaller of the two, then the other numbers, I can say the other two numbers are, and how could we get from x to 3? Are x minus 2 and, x minus 2 and x plus 2, because in order to get 2 ahead or 2 back, I would subtract 2 and I would add 2. And that's what I would use that strategy. Now, that might not be obvious to you at first, but once you've seen it once, it's like, oh, okay, yeah, that kind of makes sense to be an odd number. And we could do this with our even numbers too. If we were there just consecutive numbers, it would just be adding 1 or adding 1, and if it was a third consecutive, it could be adding 2 and so forth, okay? Now, what we want to do is create an equation. We have the 3 numbers. We have x, x minus 2, and x plus 1. And if we put them in order of smallest to biggest, I can add them together and I should get a sum of 39. So to do that, we create this equation, and this is the hardest part, is we say x minus 2, that's the smallest number, plus the middle number, plus x, and then x plus 2, and we add those all up and we get 39. So remember, smallest number, our middle number, which we're looking for, and our bigger number, which is one above it. We add them all up and it equals 39. And now it's a matter, we've created this equation, it's just a matter of solving that equation. So I combine some like terms here, x plus x plus x. So I have 3 x's that I can bring together. That gives me 3x. And then I have minus 2 and I have plus 2. Well, what's minus 2 plus 2? Oh, well, that's 0. So I don't even have to write anything down. That is going to equal 39. And so I'm most of the way to solving it. One last step. 3x is equal 39. What does 1x equal? Well, divide by 3, and x equals 13. So now I know my middle number is 13. And if I want, that means if I'm going to have 3 consecutive odd numbers, 13 will be there, 15 would be the number above, and 11 would be the number below, adding and subtracting 2. And I can actually add these up. Probably use my calculator, but 11 plus 13 plus 15 equals, and you'll see here that answer comes out to 39, exactly right. So it's just kind of like a little mental check to make sure that I actually have the correct answer. And then what's next is that I'm going to write a concluding statement, and that concluding statement would be, therefore, the middle number is 13. And I probably can get away with just making that statement because the middle number is 13 is what they asked for. I always tell students, look back at what did they ask for in the question. And so, you know, it's fair enough to say that. Now, you could go on and say the middle number is 13 of 3 consecutive numbers that add to 39. And that would be a more clear statement. There's no question about it, okay? And I don't think that that would be wrong to do that, but it is a little bit more wordy, and technically you've answered the question when you get there. Sorry, I had to just do a little editing on that question. It was incorrect, and I wanted to set it straight. So this is my next question. You should have the numbers accordingly in your worksheet. So it says, Belinda has to spend on Christmas chocolate $50. She has $50 she can throw at Christmas chocolate. Maybe she works for a company and the boss has said go out and buy the staff some chocolate, And she goes out and buys some really nice fancy chocolate bars, and she comes back to her boss and says, well, here's $14 change. I got $14 change. And she bought 16 chocolate bars. Maybe they came in boxes of 16 or 8. She bought 2. Who knows? But she bought them. And then the question that is asked of Belinda is, or you, is how much did each chocolate bar cost? And so we have a, seems like a fairly innocent question, but it's pretty straightforward. So once again, what specifically does the question ask you to find? Well, it specifically asks you, and it's often near the end of the question, but it doesn't have to be, how much did each chocolate bar cost? And so what you want to do is start with a let statement that says let, and I like the letter X be the cost of one chocolate bar. And then we're going to work towards solving for X. If we can find X, we're all set. Now again, the most challenging aspect of finding or solving this is coming up with an equation. But I ask you this question: if you buy something, the cost of it is often, if you buy one of something, it's 1 times the cost. If you buy 2, it's 2 times the cost. If you buy 5, it's 5 times the cost. Well, in Belinda's case, she bought 16, so it's 16 times the cost, which is X. So it's 16X, okay? And at the end, she still had $14 left over, so we say plus 14. And that is going to equal $50, which is what she had to start with, okay? And this is by far the most challenging aspect of solving equations, being able to break down the word problem and come up with an equation, okay? So again, it was 16 chocolate bars times the cost, and that was what it cost her to buy the chocolate bars. And then she had $14 left over, so add the 14, and she had $50 to start with, so that was the total amount of money she had. So that's how we created that equation. Now it's a matter of solving it. So I'm going to subtract 14 from both sides, minus 14 from both sides, and I end up with 16x equals 36. Okay, now I want to solve for x, so I'm going to divide each side by 16, and I get x equals, well, that doesn't look like it's going to be a whole number, so I'm going to grab my calculator and I'm going to go 36 divided by 16, and it works out to a perfect $2.25. Okay, so $2.25. Does that seem like a reasonable cost for a chocolate bar? Well, in today's world, yeah, sadly, it does cost that much for a chocolate bar. So I'd say you're probably on track. Most chocolate bars are cheaper, but this was a Christmas chocolate bar, a little nicer one. So maybe $2.25 seems like a reasonable amount. Okay. And it's good to give yourself that thought process. Ask, does my answer seem reasonable? Okay, now my final part of the question is to write down a concluding statement. So therefore, the cost of each chocolate bar is $2.25, and away we go. Notice that at this point I add the dollar sign because it is money. That's important. If there was units, it was distance or something like that, and units would go in there, and we essentially have completed the question, answered it. We asked how much did each chocolate bar cost, and you gave an answer for that. All right. Hopefully this was helpful, and you can go and attack some of the questions that are in the worksheet and get through them. Again, ask questions. It's okay if you struggle with figuring out the equations at first. I have no problem helping students kind of work their way through that. Usually once you've seen it once or twice on different examples, it usually starts to come together and you get better. We develop skills with practice. And if you don't practice and you just have to do this right off the bat cold, it's quite often very difficult. It's no different than maybe putting on a pair of skates and trying to skate for the very first time. I wouldn't expect most people would do very well. So you need to do your practice. So enjoy.